Thank you. Hello, everyone. Welcome and thank you for joining us to learn about AWS today. My name is Rajdeep Banerjee and I am a senior solution architect at AWS. And today we are going to discuss about event-driven architecture using serverless technologies with AWS. Thank you again for joining and let's get started. So in the simplest term, what is an event? An event is a signal that a system state has changed. An event-driven architecture uses event to trigger and communicate between decoupled services, and it's very common in modern application built with microservices. An event can be a change in state or an update, like an item being placed in a shopping cart on an e-commerce website. Events can either carry the state, like the item purchased, its price, its delivery address, or events can only be identifier, like a notification that an order was shipped. Request reply interaction using RESTful APIs, they have a tight coupling of application, like direct connection between them. App A asks App B for information, and App B sends App A the requested information. But event-driven architecture is often chosen due to its promise of decoupling the services involved. What is coupling? It is a measure of independent variability between connected systems. Decoupling has a cost, both at design and runtime. And coupling is also not binary, and it is not one-dimensional. It has many facets, like you can have a technology dependency between two systems, you can have a location dependency in terms of IP address. Your two systems can have different data formats or data type, or you can have a semantic dependency between the two systems. And there can be interaction or conversation dependency between multiple systems. As architect Gregor Hopp says, the appropriate level of coupling depends on the level of control you have over the endpoints. So event-driven architecture helps you to decouple the application components. Event-driven architecture typically have three key components: event producers, event routers, and event consumers. A producer publishes an event to the router, which filters and pushes this event to the consumers. Producer services and consumer services are decoupled, which allows them to be scaled, updated, and deployed independently. Here, event router is the core component that abstracts producer and consumers from each other. You can publish to the router or consume from it without knowledge of other producers or consumers. At AWS, we have event routers like Amazon Event Bridge or SNS, Simple Notification Service, that we will cover later. Events are often asynchronous. You don't need to wait for a response to move on to the next step. This improves your architecture resilience and reduces dependencies. Events can also act as a buffer. They are called event store, holding on to events until the consumer is ready to use them. At AWS, we have Amazon Simple Queue Service or SQS, which is our serverless event store or queue. Amazon MQ is another queue, and it uses standard API and protocols that you may have been using today, like JMS, AMQP, Stomp, MQTT, or WebSocket. So what are the typical benefits and use cases for event-driven architecture? Scale and fail independently. By decoupling your microservices and application components, they are only aware of the event router, not each other. This means that your services are interoperable. If one service has a failure, the rest will still keep on running. And the event router will act as an elastic buffer that will accommodate any surge in your workload. Develop with agility. So you no longer need to write custom code to poll, filter, or route events. The event router can automatically filter and push events to consumers. The routers also removes the need for any heavy coordination between producer and consumer services and speeding up your development process. Logging and auditing. An event router can act as a centralized location to audit your application and define different policies like security policies. So these policies can restrict who can publish and subscribe to your router and control which users and resources have permission to access your data. You can also encrypt your events both in transit and at rest. Finally, cost saving. Event-driven architectures are typically push-based, so everything happens on demand as the event presents itself to the router. So this way, you are not paying for continuous polling to check for an event. This means less network bandwidth consumption, less CPU utilization, and less SSL or TLS handshakes. What are the common use cases? Well, you can use event-driven architecture for cross-account or cross-region data replication to coordinate systems between different teams operating in and deploying across different geographic regions and accounts. By using an event router to transfer data between these different systems, you can develop, scale, and deploy services independently from other teams. Resource state monitoring. Rather than continuously checking on your data or resources, you can use an event-driven architecture to monitor and receive alerts on any anomalies, changes, or updates. Now, these resources can include your storage buckets, database table, or any serverless function or compute nodes. Fan out and parallel processing. If you have a lot of systems that need to operate in response to an event, you can use an event-driven architecture to fan out the event without having to write custom code to push to each consumer. The router will push the event to those systems, and each of which can process the event in parallel with a different purpose and logic. Finally, integration of heterogeneous systems. If you have systems running on different technology stacks, you can use an event-driven architecture to share information between them without tight coupling. The event router establishes indirection and interoperability among those systems, so they can exchange messages and data while remain agnostic themselves. So we all have heard about AWS Lambda-based microservice model. AWS Lambda is one of the most popular serverless event-driven compute service, and we can invoke Lambda in different methods. So when you invoke a Lambda function, you can choose it to invoke synchronously or asynchronously. With synchronous invocation, you wait for the function to process the event and return a response. With asynchronous invocation, however, Lambda queues the event for further processing and returns a response immediately. For asynchronous invocation, Lambda handles the retries and can send the invocation record to a particular destination. Lambda can also poll to an event stream or queue. To process item from a stream or queue, you need to create an event source mapping, which is a resource in Lambda that reads item from a simple queue service or Amazon Kinesis or DynamoDB stream and sends them to your function code in batches. Each event that your function process can contain hundreds or thousands of items. Now, let us take a quick look at 4 different services available on AWS that allows for your asynchronous processing of events. Now, each of them provides different advantages for different types of workload and can be used together to build highly resilient, scalable, and flexible systems. First, Amazon SQS or Simple Queue Service is a fully managed message queuing service that enables you to decouple and scale microservices, distributed system, and serverless application. Amazon Simple Notification Service or SNS is a fully managed messaging service for both system-to-system and app-to-person communication. It enables you to communicate between systems through publish, subscribe, or PubSub patterns that enable messaging between decoupled microservice applications, or communicate directly to users via SMS, mobile push, and email. Amazon Event Bridge is a serverless event bus that makes it easy to connect application together using data from different producers like your own application or a software as a service or SaaS application. EventBridge delivers the stream of real-time data from these producers and routes the data to targets like AWS Lambda or your custom application. And you can set up different custom routing rules to determine where to send your data, to build an application architecture that react in real time to all of your data sources. AWS Step Function is a serverless function orchestrator that makes it easy to sequence AWS Lambda functions or multiple other AWS services into business critical workflow application. Through its visual interface, you can create and run a series of checkpointed and event-driven workflows that maintain the application state. The output of one step acts as an input to the next, and each step in your application executes in order as defined by your business or workflow logic. So over the next few slides, we'll look at how an event-driven architecture allows us to scale and simplify a growing e-commerce site. Now, this is a standard synchronous API-based service. In this case, when a client makes a request to the order service, it has to make a downstream request to the invoice service. Once it gets a successful response, it can respond back to the client with a success message, maybe provide a confirmation number, and the customer is happy. And this works great when you have got a nice, simple system like this. But how do you support a growing number of services as your store operation grow? What happens when you need to add a new service? There is nothing wrong with having a lot of systems that are interested in the data of the order service. What is problematic is that in this API-oriented design, the order service needs to know all the other services. Now we talk a lot about how great microservices are because they are decoupled. But the order service still needs to know how to locate the other endpoints. It needs to understand how to make the appropriate API calls, what to do if one of these calls fails. It needs to have appropriate retry logic and error handling and all the other logic and code baked in for each of the services it talks to. Now we can use EventBridge to intelligently route events to the right downstream services asynchronously. The downstream services can perform its work and move on. I'm sorry, something. Give me one moment. Yep. So here you can see, we are sending a JSON containing all the details from the order service to the EventBridge service. Here you can see the source that's coming from the order. You can see the order details like order ID, price, member ID, and other details. And using EventBridge, you can easily filter events that send, Ron, can you still hear me?
Yes, I can hear you.
Okay, sorry, I think I lost my share. Okay, anyway, sorry about that. Something internet issue, but yeah.
Hey,
so using
let me
EventBridge as a
Rajdeep, one quick question. Interesting. One of our individuals had a question about his application requires replicating zettabytes of data. I know you may need more specifics, but how does this particular approach handle replication? I would imagine it's better because when you get more granularity in your application architecture, when you could separate different activities, you don't have to do a monolithic replication of a huge service. You can segment it and be more efficient. Is that reasonably correct?
That is correct. We have services that can, do replication of data. If I can get some more context around this request, I can definitely give a more concrete answer. But yes, AWS has multiple services to provide replication data seamlessly.
And just, from a 30,000 foot view, the whole premise here, as you're listening to this, fairly technical talk, is it's really talking about how do you build and design your cloud architecture to not support monolithic applications, but more modern applications, cloud native designs. And you need to understand this methodology so your cloud architecture helps your organization thrive and be flexible. Okay, all yours,
Thank you.
Raja.
Sure, thank you. So as I was saying, using Event Bridge, we can easily filter events and send only to the downstream services that need the data. Here, Event Bridge is ingesting, filtering, and delivering events without writing any custom code, so that you don't have to write the code in the order service. Based on the source, you can route it to the appropriate service using Event Bridge. And tomorrow, if you add a loyalty program, instead of rewriting the application or changing the order service, you can add a new filter rule to the Event Bridge. So if there is a new member ID in the event, then send that event to the loyalty service for processing. So as you can see, this allows us to choreograph the flow of events in the system and maintain the boundaries between the services. So relative to managing a monolith, as Ron was mentioning, this is much simpler to implement and has a more cleaner path. And it is very easy to understand the flow of the system. So let's take a look at how Event Bridge works. So Event Bridge connects application using events. The producers send event to the Event Bridge. Now, in order to write code to react to this event, you need to know the event schema, which include information such as title, format, and validation rule for each piece of event data. The Event Bridge schema registry stores a collection of all these schema generated by your organization applications. You can download this code binding for this schema into your own development environment, VS Code or Visual Studio, which enables you to represent the event as a strongly typed object in your code. A rule matches incoming events and routes them to target for processing. A single rule can route to multiple targets, and all of which are processed in parallel. A target processes these events, and targets can include anything like your Amazon EC2 or virtual machine, Lambda function, or step functions. A target receives these events in a JSON format. Now, there are numerous patterns in the enterprise, and that can be enabled via event-driven architecture. Here, we are showing two most commonly used patterns. In the first, client is sending message to an Amazon SQS queue. SQS offers a highly scalable, reliable, hosted queue for storing messages as they travel between application or microservices. It moves data between distributed application components and helps you decouple these components. Amazon SQS also provides common middleware construct like dead letter queue for error processing and poison pill management. SQS supports both standard and FIFO or first in, first out queue. On the consumer side, you may have a Lambda function that is reading the messages and saving them to Amazon DynamoDB table. In the other publish subscribe pattern, an application is publishing a message to Amazon SNS topic. SNS also provides developer with a highly scalable, flexible, and cost-effective capability to publish message from an application and immediately deliver them to multiple subscribers listening to that topic. In this use case, you have a SQS queue that is subscribing to this topic. A Lambda is polling the queue, invoking your function code, and saving the information to a DynamoDB table. Another SQS queue subscribing to the same topic, an application Lambda applying some logic and then publishing the message to another SNS topic for further fan out of your event. Finally, you can also trigger a Lambda function directly, and this function is invoking a step function workflow. So by default, an Amazon SNS topic subscriber, they receive all the message that you publish to the particular topic. However, you can use SNS message filtering capability so that each subscriber can get a subset of messages based on your business rule. Now we talked about choreography using Event Bridge, right? But there are some use cases that requires orchestration. Now, orchestration is based on the idea of a central system that controls all the interaction between various elements of your system or microservices. Here, you can see a new account opening application that has a series of workflow components like know your customer, check the customer, review, approve the process. Orchestration pattern is very useful in this type of typical workflow scenarios. In this approach, there is a central service that acts as a controller and handles communication between individual microservices. At AWS Step Function provides serverless orchestration for modern application. Orchestration centrally manages the workflow by breaking it into multiple steps. As your application executes, Step Function maintains the application state, tracking exactly which workflow step your application is in, and stores an event log of data that is passed between these application components. That means that if your network fail or any components hang, your application can pick up right where it is left off. So your application development becomes much faster and more intuitive with Step Function because you can define and manage the workflow component of your application independently from its business logic. Making changes to one does not affect the other, and you can easily update and modify workflow in one place without having to struggle with managing and monitoring multiple point-to-point integration. And we can use Amazon State Language, which is a JSON-based structured language to define your state machine. State machine it is a collection of states that can do a particular task or work. Determine which states to transition to next if it is successful, or it can stop the execution when an error happens, and so on. So Amazon Step Function is a very powerful workflow orchestration tool from AWS. But if you are familiar with or currently using Apache Airflow, which is an open source workflow management platform, you can adopt a managed Apache workflow. So AWS managed workflow leverages the same open source Apache Airflow product, and it made easier to use it in the cloud. It is fully managed by AWS with auto-scaling capability, and has built-in security and authentication enabled. You can use Amazon Virtual Private Cloud or VPC, and data is automatically encrypted using AWS Key Management Service or KMS. So your workflow environment is secure by default in the cloud.
Hey, Rajdeep, we've got about
Yes.
a minute left, so I'm going to ask you if you could just summarize some of the key takeaways, if you don't mind, as we want to keep things moving.
Sure, I will take a minute only. So lastly, some use cases may require a hybrid approach, combination of orchestration and choreography. So we can use AWS Step Function to orchestrate your workflows and send an event to Amazon Event Bridge to choreograph events further into downstream consumers. And based on different rule set, a consumer can read the message from the bus and do parallel processing. So I hope you all found this webinar useful. Now, for a further deep dive on this subject, you can visit serverlessland.com, where you will find many useful patterns across industries. You can also talk to your AWS account team to arrange specific workshops or training on serverless topics. Thank you all for attending the session, and I hope you all have a nice day.